Namaste dear friends, welcome to Math Art Studio. Today I am going to discuss further in detail with graphical applications of enlargement. I hope you will enjoy it. Dear friends, last time in my previous presentation I had concluded that area of the image equals to k square. K is the scale factor times area of the object. So we are just trying to analyze this somehow in different way. Let's make a table of area of the object and the image. So you have here figure number and scale factor and object area, and you have image area, and I have made some adjustment in the formula. Okay, so let's have these things. Assume that you have an object of given area 1. So the object has the area 1 unit, square unit. And in figure 1 we have the scale factor 1. And when there is the scale factor 1, the square of this scale factor is 1 square equals 1 into 1 is equal to 1 unit. We have this one. And in the second figure, you have further enlarged this thing with the scale factor 2, and object area is 1. You have 2 square into 1. Scale factor square into 1, it's like that. That is equal to 4. And in this one, figure number 3, scale factor is 3, area is the same, and 3 square is 9. You can write 9 into 1 equals to 9 square units. And in the fourth figure, scale factor is 4. Different scale factor we are using. And we'll test the fractional scale factors also. And we'll take a different area also. But for this presentation, we have the area 1 unit everywhere. And this is 4 4 is 16 into 1 is equal to 16. And the adjustment we can make is, this is 1 into 1 square, and that one is 1 into 2 square, and the adjustment something like that, and that's 1 into 3 square, and that one is 1 into 4 square. So this gives us the area which is obtained here, the image area. And as a generalization, what we can do in generalization, let's assume the image area as y, object area as a, and scale factor as x. So that is x square. This is our generalization. And in this one, let's have some explanation. And the explanation here is this y is image area. This A is object area, and this x square is scale factor. X is scale factor. Let me write x only. X is scale factor. So this one is the explanation, and that one is the generalization. What is the generalization? The area of the image is the square of scale factor multiplied by object area. So that is the generalization. And with this generalization, we will draw the graph. Let's try this way. You have the axis here, x-axis, and you have the y-axis here. Okay, and in this one, let us calibrate the unit. 1, 2, 3, 4, 5, etc. -1, -2, -3, -4, -5, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, so on, it goes up. And in this one, when the scale factor is 1, the image area is 1. Let me use the red marker. When scale factor is 2 and the image area is 4, 1, 2, 3, 4. Here, I'm looking at here, 1, 4, 9, 16. And 3 is 9 over here. And 4 is 16, that is up here. So you have a curve like this. You have a curve like this. And the area would be positive even if the scale factor is negative. For example, let me do it here. So our area is 1 unit and scale factor is -2 units. So then what is this? This is 2 to the 4, again 4. This is the same as the one with scale factor 2 over here. Therefore, it works for the negative scale factor as well. That's why 1 minus 1, that is 1, 1 minus 2, that is 4, and 1 minus 3, that is 9, and 1 minus 4, that is 16. It's like that. So let's draw it also. Look, what a lovely generalization is this. I'll write lovely generalization. Why lovely generalization? Because when we graph area, this y is area of the image against the scale factor, x is the scale factor, then we get the quadratic graph, the parabolic graph that represents quadratic equation. In fact, this is y equals to x square. That's the very elementary quadratic function. And let's see what happens with area of the object equal to 2. What happens? Let's see that one and graph it also. Y equals to ax square is our formula. In this one, we try the area equals to 2x square. The coefficient of the square term in quadratic expression is 2. And with this one, y is equal to 2 into 1 square equals to 2. Y equals to 2 into 2 square equals 8. Y equals to 2 into 3 square is equal to 18. And y equals to 2 into 4 square is equal to 32. And so on. Let's graph these points. The order appears. When it is 1, that one is 2. The area is 2. When it is 2, that is 8. It is here. When it is 3, that is 18. 18 is somewhere up there, We don't have space here, that's why that's up there. Similarly, it works for negative scale factor also. Therefore, we have this situation. And then if we go joining this free end, we'll have again the parabolic shape. And this is y equals to 2x square. And again, let's go for fractional scale factor. Now we have the quadratic function ax square. And in this one, we are taking a equals to 1 by 2. Y equals to 1 by 2. Scale factor is 1. The area is half. Y equals to 1 by 2, the scale factor is 2, area is 2. y equals to half, the scale factor is 3. The area is 4.5. Y equals to 1 by 2, scale factor is 4. The area is 8 square units, you know. So with these values, let's draw the graph again. When x is equal to 1, y is equal to 1 by 2. X is equal to 2, y is equal to 2. X is equal to 3, y is equal to 4.5. 1, 2, 3, 4.5, somewhere here, you know. And y equals to 4, that is 8. 8 is somewhere here. And it works exactly in the same way for negative scale factor also. That's why you have the corresponding points over here, this way, and that. Now if you draw it, you'll get another parabolic shape, you know. And this one is y equals to half x squared. Our generalization for today is that when we multiply the area 1 by 2, that means we take the constant equals to 2, and the curve becomes like this. This is also the parabola with narrow mouth over there. Narrow mouth. If it is 3, it will be still narrower. Will go toward the y-axis. And when it is half or fractional, and it would be open. And all these curves are explained by two different terms by different mathematicians. For example, someone used to say dilation. It is very much related to enlargement, but I'll not go for that really. And others say it is a kind of stretch, and it is the stretching of the curve y equals to x squared with different scale factor and different areas. So this way, if we go for graphical representation of our finding whatever is it, and this gives a very new and amazing result, very new and great experience to us, and a kind of finding, new finding, and this type of finding is very rare with people. Perhaps people have not graphed the area this way, and if they have not idea about that, I hope they will be benefited from this one if they have this idea already, and it would be a kind of revision to them. Thank you, dear friends, watching me. Keep watching Math Art Studio. You will be having new concepts and methods of teaching mathematics, learning mathematics, and utilizing mathematics in our daily life. Thank you.